us solve the one more problem. Find the Laplace transform of cos square 2t. So do we have any formula to solve directly as if the Laplace transform of cos square theta? No, we don't have. Unless it should be expressed in terms of the known formulae, that means in terms of cos theta, that means for example cos square theta is there. But here we have the cos square 2t, that's why it should be expressed in terms of cos of multiple, that in terms of t we need to write it. So with the help of the multiple angles formulae, that means for example we have 2 cos square theta is equal to 1 plus cos theta, whereas cos square theta is equal to 1 plus cos theta divided by 2. Just in the place of theta you replace 2t, so that the cos square 2t can be written in terms of cos t, that means cos 4t in terms of, so that we can apply the Laplace transform of cos at whose formula is s by s square plus s square. So this kind of strategy is to be followed in order to solve this problem. Now let us proceed for the solution now. We know that 2 cos square a or theta, you can write no problem, 1 plus cos 2a. Okay. So let us write the value of cos square a. Cos square a equals to 1 plus cos 2a divided by 2. But we need the value of cos square of 2t. That means instead of a replace 2t. So therefore cos square 2t can be written as the 1 plus cos of 2 into 2t 4t by 2. That means in order to find out the Laplace transform of cos square 2t, it is enough to find out the Laplace transform of 1 plus cos 4t by 2. So that can be done very easily using the basic formula, elementary formula. So let us solve it now. Now Laplace transform of cos square 2t. So now we are going to evaluate the value of this one. So this can be written L of 1 plus cos 4t by 2. Am I correct? Now 1 by 2 taken common. So this can be written 1 by 2 times Laplace, that means L of 1 plus cos 4t. Now once again we can apply the linearity property. So this can be written as 1 by 2 times the Laplace of 1, transform of 1, or L of 1 directly you can say, plus L of cos 4t. Okay. Here the two basic formulae need to be applied. So that is Laplace of constant is 1, that is 1 by s, whereas Laplace transform of cos at, it appears to be s by s square plus s square. So even we can write the formula also, no problem. L of 1 is 1 by s, whereas L of cos at equals to s by s square plus a square. So with the help of these two formulae, now the problem can be solved. Here of times Laplace of 1 is 1 by s plus Laplace transform of cos 4t or L of cos 4t. That can be written directly s divided by s square plus 4 square. Now we need to simplify. that is 1 by 2s plus 1 by 2 multiplied by this one, s divided by 2 times s square plus 16 . One more problem. Find L of sine cube 2t. So how do we solve this problem? So this problem can be solved using one of the trigonometric formulae from multiple angles, that is sin 3a formula. So we need to recall sin 3a formula. What does sin 3a stand for? Sin 3a equals to 3 sin a minus 4 sin cube a. Now here we need to express the sin cube a value in terms of sin 3a and sin a. After that, in the place of a, if you just replace 2t, the sin cube 2t can be expressed in terms of sin t and as well as sin 3t. So that easily we can apply the basic formulae in order to find out the Laplace transforms. So the method has to be adopted, or strategy has to be adopted to solve this problem. This problem is very important problem, and in most of the board examinations this question may be asked for engineering M1 mathematics 1 examination, but whereas for the diploma students, polytechnic diploma students, so this question may be asked M4, the mathematics 4. So that means that you need to concentrate on these type of questions. So let me solve the question using whatever strategy we planned. So now the solution follows. We need to recall the formula, sin 3a formula. We know that sin 3a, 3 sin a minus 4 sin cube a. Am I correct? So let the two terms we need to transpose it. Bring minus 4 sin cube a this side, sin 3a that side. So we get the 4 sin cube a equals to 3 sin a minus sin 3a. Our aim is to determine the value of sin cube a. So now we can write the sin cube a is written as 3 sin a minus sin 3a divided by 4. So now let us write the value of sin cube 2t. That means a is replaced by 2t. So therefore sin cube 2t, 3 times sin 2t and minus sin of 3 times 2t, whose value is 60, it becomes 60, divided by 4. So in order to find out L of sin cube 2t, it is enough to find out L of 3 sin 2t minus sin 6ct by 4 only. So let us solve it now. Now L of sin cube 2t. Are you following? This sin cube 2t is replaced by Laplace transform of 3 sin 2t minus sin 6t by 4. Using the linearity property, this 1 by 4 shall be taken common out. This we can write 1 by 4 times L of, that means 3 times L of sin 2t. Okay, now you can expect the next step. The minus L of sine 60. Here only one of the basic formulae need to be applied here. So that is the Laplace transform of sine 80. So that is a divided by s square plus a square. So with the help of only this formula, this can be solved now. So now the 1 by 4 times 3 multiplied by, this is sine 2t means 2 divided by s square plus 2 square, and minus, you can expect the value of Laplace transform of sine 60, that is nothing but 6 divided by s square plus 6 square. So now we need to simplify it. So this can be written, we need to distribute 1 by 4 to the first term as well as to the second term. So this will be 1 by 4 times 6 divided by, because 3 into 2 6, s square by 4, and minus 1 by 4 times 6 divided by s square plus 36. Next, 2 2 ja, 2 3 ja. So now this can be rewritten as 3 divided by 2 times s square plus 4 and minus 2 2 ja, 2 3 ja. 3 divided by 2 times s square plus 36. So this is the answer.